Starting out chapter 4, it's all about quadratics with x squared and dealing with parabolas. You should write this down if you have no idea what a parabola is. First thing you have to know what a parabola is dealing with x squared. So you have x squared like this, or this would be in vertex form, with our vertex being hk. That's the vertex of the parabola. This is going to be your parent function. So your parent function always has the vertex at 0, 0. Now the other thing you have to look at is this dotted line right here. This is your axis of symmetry. That means that on both on the left and the right hand side of the axis of symmetry, it's like a mirror image. So again, write that down if you don't know any of that information. Another thing to talk about with parabolas or quadratics is we're always going to have a maximum or a minimum, depending on if it's a reflection or not. If there's no reflection, that means it's going to be a minimum value, meaning that your vertex is at the bottom. That's the lowest it will ever go. If it does reflect, or if A is negative, then that means it's going to be flipped, and that means it's going to be a maximum value. We also have our stretch if A is larger than 1, like what we had in Chapter 2 and Chapter 3, or if A is less than 1, not including the negative number, because that means it's a reflection, then it's going to be compression. And just like transformations that we've had before, this would be my standard form where y is equal to ax minus h squared plus k. Again, if anything on the inside, it's always opposite, moves left or right. That's this part. Anything on the outside of the equation, that moves up or down, and it is as shown. So if it says plus, it moves up, negative moves down. That's this part. So my actual vertex is my hk. The h is always going to be also my axis of symmetry. So if I give you an example, right here, my vertex is going to be my hk. So since this shows a negative, my h is going to be a positive 3. And since this shows a negative, this would be a negative 4. Now my axis of symmetry is always going to be my x value. So this is where x would be equal to 3. This is the point where my dotted line would move up or down. Maximum or minimum, and where point, this would be a maximum because a is negative. That means y, my maximum point here would be y is negative 4, and it'd say a maximum. My domain and range now. Domain is always what values x can be. Range is always what values y can be. So I'm going to sketch a graph over to the right. But before I sketch my graph, I want to make sure that I have points that are correct. My vertex is at 3, negative 4. So I'm going to pick two numbers on the left side of 3. So I can pick 1, 2, 3 is where my vertex should be, and then I'm also going to pick 4 and 5. When you're plotting a parabola, you should always have 5 points, 2 on each side of the vertex. So if I plug 1 into my equation, again, using this equation up here that was given, plug 1 in, you should get a negative 6 out. Now pause the video and finish filling out this table. Now if you see here, from your vertex, it should be a mirror image. So it should follow the same pattern on the left and right hand side. Now I'm going to draw this graph. So at a positive 1, I'm going to go down 6, plot that point. At a positive 2, I would be at a negative 4.5, so about right here. And then at 3 would be at negative 4. And then again, it should be a mirror image on both sides, so about right here. So this would be my graph. So now this is going to help me figure out what my domain and range is going to be. My domain is always how far left do I go and how far right do I go. So if I look at my image, how far left I go, it's going to infinity. So my domain is going to be from negative infinity, and now I'm going to look how far right do I go. This is also going to infinity because there's an arrow. So it's going from negative infinity to infinity. Now my range, it's how far down do I go. If I look down, it's pointing down forever. So it's going negative infinity. And how far up do I go? This is the highest point that I can go up, which again is my maximum. The highest point here would be at negative 4. And I'm going to put a bracket on that because it includes that number. So my range is going to have whatever your maximum or minimum number is going to be. And that would be your domain and range. So what does the graph look here? The only one transformation I have is going to be a 1/2. Should fill out a table with 5 points and attempt to graph. And this is what your graph should look like. You should always have arrows on both ends. Again, nothing different than what we have been doing with transformations. Your HK is still 0, 0. It doesn't move left or right. So it's basically just a compression. It's getting wider. Attempt to graph these two functions. Again, noting the transformation or the translation from the parent function. So these are what your two graphs should look like. On the first one, it moves down 5. So it's still the same as the parent function. It doesn't move wider or stretch. And on the B, it would move a right 4. So it just moved right 4, and then we'd still have those same 5 points. We're going to practice one of these again. So if I look at my first problem here, I'm going to want to graph this, but first I'm going to figure out all of this information on the left, and that's going to help me graph. My vertex, on the inside, it doesn't move at all, so it's a positive 4. Outside, it's down 2. Your vertex will help you with both the axis of symmetry and your maximum or minimum. My axis of symmetry is always going to be whatever my x value is. So x equals 4 is going to be my axis of symmetry. Again, that mirror line. And in this case, this 3 is a positive, so it's going to be a minimum value because the u would look like that. So my minimum is going to be where y is equal to -2, and I'm going to write min. The domain range I'm going to do after once I graph this. And you should use your 5 points to help you graph. So 2 points on the left of your vertex and 2 points on the right. So I would use 2, 3, 4, 5, and 6. Again, I'm going to pause the video and fill out the table. So your table should have that mirror image from the vertex. And then this is what my graph will look like. Again, here is where the axis of symmetry, where x is equal to 4. And also this would be my minimum value because that's the lowest point, and that's where y is -2. So that's, again, going to help me figure out my domain and range. So when I look at my domain on the left-hand side, how far left do I go? There is going to be an arrow. So that means I go from -infinity, that's an infinity sign, to, if I look on the right-hand side, it's going to be another arrow, so it's going to be to infinity. You want to use parentheses here because they go on forever. So range is how far down do I go? How far down? I have an actual spot how far down. My lowest point, again, my minimum, is going to be at -2. And it includes that number, so I'm going to put a bracket from -2, and how far up do I go? I go all the way to infinity, and then a parenthesis. So that would be my domain and range. Right now I want you to attempt this whole problem by yourself and check your work. So push pause, do it yourself, check your work, make sure you have this in your notes. So this is what your answer should be. Your vertex would be a +1 and +3. Axis of symmetry is x equals 1, so that would be the dotted line that goes through your vertex, and it should be a mirror image on both sides of your axis of symmetry. In this case, it's going to be a maximum because there's a negative in front right here, so this would be your maximum point, and that's where y is equal to 3. So your domain is how far left is -infinity, how far right is infinity. Again, that's because it's going to arrows. How far down is going on forever, so it's a -infinity, and how far up, +3. And here is my table that I use to help me graph. Make sure you have all this information written down and have all graphs in your notebook. Have a great day.